So when we look at all of these spectra for different types of stars, we start to see patterns. And the person who did this originally was Annie Jump Cannon, and she looked at all of these stars and looked at their spectra, and she ordered them in alphabetical order because at that time we didn't understand the significance of those lines. And that's been rearranged now. So basically, like, the hottest star is now an O, and the coolest star is now an M. And we end up with these spectral classes, which O, B, A, F, G, K, M, which basically we can remember by saying, "Oh, be a fine guy, kiss me." And we say guy because it was Annie Jump Cannon. So assuming, highly likely that's what the original, that's how she would have thought about it. Most likely. Okay, so when we look at an O star, for example, that's going to be a really hot star, and it's going to have those ionized helium lines in its absorption spectra. And that star is going to be blue. So just like if you think about like really simple stuff, like you think about like a Bunsen burner flame, when it's cooler, it's like orange and red, and when it's hotter, it's blue. When we heat up a piece of metal, it basically goes through oranges and reds, yellows, and then ends up blue. So really hot things are actually blue, and cooler things are red. So we can use these spectral classes to work out the color of a star. I mean, we can also just look at it because the color you see is basically a reflection of what temperature it is. But also we can basically tell how hot the star is from these spectral classes. Now, it gets broken down even further. So each of these classes have classifications. So an O star has classifications from 0 to 9. And so do all the others. So, for example, G has classifications from 0 to 9. The sun, our sun's name is Sol, by the way, if you didn't know. So it's actually a G2 star, which means that it's like a little bit hotter than a G1 star, and it's a little bit cooler than a G3 star. And if you have a look here on the spectral class table, you'll see that means it's between 5,000 and 6,000 Kelvin. It's a yellow star, and we'll see ionized calcium lines in it, which is really cool.